The way data deduplication works is it will scan the file system for any file meeting your optimization policy. Now, an optimization policy would say something like, if a file has been modified and it's been more than 3 days since the modification, I want to deduplicate that file. Maybe you want to wait 3 days because you have some files that change on a daily basis. You don't want to dedupe those because you may be in a constant state of having deduplication run. So you want to wait a certain number of days, 3, 5, 7, whatever you believe appropriate. So we'll configure these optimization policies to determine how that works. Well, this is going to go through and just find files that meet the optimization policy. The second step is to take those files, and they are broken into these chunks. Basically, it's going to take your Word document and chop it up into a bunch of pieces. It's going to do the same for Excel, Visio, other types of content, and then it's going to look for any chunks that are duplicate. So looking at this graphic, you'll see there are 3 alpha or A chunks. 2 in the Microsoft Word document, 1 in the Excel spreadsheet, meaning that piece of data is the same across all 3 of those chunks. You'll see the Bravo or B chunk is unique. There's no duplicate of that chunk. And we'll see the Charlie or C chunk. The spreadsheet and Visio both have that. Then the Delta or D chunk is duplicate. And the E chunk is a singular chunk, not duplicated anywhere else. So what I want to do is take the A chunk, the C chunks, the D chunk, and I actually want to store those in my chunk store. And when we do that, I'm going to store just 1 copy of the A chunk, 1 copy of the C, 1 copy of the D. That is going to allow me to conserve space. Now we're talking about 3 files. If you extrapolate that out across hundreds of thousands or millions of files possibly, you can have a significant space savings. So now that the chunks have all been identified, we will place them in the chunk store and they become compressed in that chunk store so we can have even more space savings. Now, once they're in the chunk store, from those 3 files, I'm storing 1 A, B, C, D, and E chunk. But it actually stores in a table these file definitions. So it knows if I go back to file 1, I need chunks A, B, and A. Now in our example, that's Microsoft Word, file 1. The Microsoft Excel, file 2 needs C, A, and D chunks. File 3, the Visio needs chunks C, C, D, and E. So we store 1 copy of each of those chunks, whether it was a duplicate chunk or if it was just a unique chunk itself, we just store 1 copy of it and we have our space savings. Now, when my user goes and clicks on one of these files, it has to replace the chunk, has to add it back to the file so the file actually opens. So what it's going to do is use what's called a reparse point, and that's going to go to the chunk store. And if I'm opening file 1, it's going to say, okay, I need chunk A and I need chunk B. Now we have 2 chunk A's in file 1, but it'll just pull one of those chunks and knows that piece of data is going to be referenced twice in that file and essentially recompiles that file for you. If you make a change to the file and save it, it just generates a new chunk, goes through the dedupe process to see if it's a duplicate chunk. Whether it is or is not, ultimately gets stored in that chunk store.